Good day everyone. My name is Wajeneza Samiati and today I'm presenting my database assignment based on a student registration system. And the purpose of this system is efficient management of student information and department, courses, lectures, and student enrollment. Within academic system, the main users of this system or database are students, lecturers, and administrators. Firstly, I began my project by clearly defining the problem domain in the system and identified the key entities required for the system, which include student entity, course entity, lecture entity, and enrollment. In addition, the department student entity is here to store student information or student personal details. Course ID or course entity is here to store the course information. Lecture to store lecture details. Enrollment links students their courses, and department organize the courses and their lectures. After identifying the entity, I perform database normalization as the organization of database or information in database to implement data integrity and prevent data redundancy. I first started with a normalized form. Here we have a student registration or student tables with attributes as student ID, student name, course, lecture, and lecture phone. Here in course column we have more than one value which violated the atomicity laws in database. The problem in this table is some tables have or some columns have a multivariates we have in course in lecture. Data repetition difficult to update. In the first normal form, we have to implement atomic or atomicity laws to make each column contain its own values, or to make field with only one value. Here we separated this DB and website, and here we separated name of lectures, John and Mary. Now, as the result, each cell has one value. The repetition group removed still, but this table still have redundancy, at least appear twice. And then we go to the second normalization or second normal form. The first we have to make first normal form, and then we go to a second to prevent or to remove partial dependencies. Here in the second we have separated tables to prevent partial dependencies. We have student table, registration table, or course registration tables, lectures. Here partial dependencies are removed in second normal form. And then after we go to third normal form to make it a way of transitive dependencies. Finally, we have the student course with student ID and student name. Again, we have course entity with course ID and course name. And then we have lecture with lecture ID, lecture name, and lecture phone. Then after we have enrollment table, which contain the relationship between course and the student, with student ID, course ID, and lecture ID as the weak entity in this database. The solution from the both first, second, and third normal form is now no repetition groups are appearing, no partial dependencies, transitive dependencies or are removed, data is full, normalized, data is efficient and consistent. And the next step, I drawed an entity relationship diagram which shows the relationship between different entities. Here are students which have relation with enrollment, and enrollment have relation with course, and it created the relationship between course and the student who had enrolled in that courses. Here are relations that appear in tables. We have students with enrollment, they are one-to-one relationship. Student or course and enrollment, one-to-many relationship. Student course, many-to-many. Department and course, one-to-many, and department with lecture, one-to-one. A data dictionary here, we have a student table, we have student fields or columns, student ID, student name, and email with their data type, size, constraint that occur, and descriptions. The next step is database implementation or database and table creation. Here we created database by query of create database and then database name. And to access that database, we used database as our database called student registration. Here are the tables we created. The table, we have department tables with data, and student table with data, course, lectures, enrollment. And the 7th point was SQL queries. Here we have select. We selected all from student table or entity. We have this, and select some columns from a student entity. Is here we have select student ID, email from a student here as a result. And then we have used a condition where clause in this selection select all from the course where course name is equal to accounting. Here is the result. Here as aggregate function we use it to count a number of rows. Select count all as number of rows from the student. Here we have in the student table we have 5 records, and here we have to calculate the sum. Queries say that select sum column name or enrollment as a sum from enrollment. And then we have filter with condition. To retrieve record using multiple condition with AND. Here, select all from lecture where department equal and lecture name equal Mr. Patrick. Here is the result. And we have to select some data between the stated condition. Here we have select all from enrollment where enrollment ID between 1 and 3. Here we have to retrieve the multiple table using joins. Here the first we use inner join. We selected all table from all table or two tables, and we use it to inner join to select the common data in these tables. After we use the left join, and then we applied the right one as the types of join. We use it the nested or subqueries where close to filter. Here as query, select student from student entity where student ID in select ID from enrollment. Here we have a result in SQL. The next we use a subquery to find record not present in another tables. Here the next is to perform updates and modification on the table we have or entity we have in our database. Here as a command to modify, we have select student from student where student in and as query of update we have update student set email equal where student ID is equal S1, or have to delete a column or allow from the specific condition. We have delete from enrollment where enrollment ID is equal to, and this is the result. We go to the next with date and time queries. Here we select current date as current date. Here is the result, and here to select year from the current result is 2026. As conclusion, the project helped me again to gain practical understanding of LEO, word database design, normalization technical, ERD, and the SQL implementation. And if you want to learn more about, you can follow these links at YouTube channel. And in conclusion, we have this project helped me to gain practical understanding of LEO word and design normalization ERD, and it is also strengthened my ability to design a structured and efficient database system for academic environment. Thank you very much for watching and listening. I really appreciate